the next thing we're going to talk about in example number 3, and write this down, we're going to talk about truth values. So when we make these statements, I remember when I took, which class did I first do truth tables in? I think it was discrete mathematics. Although we did it, I also took non-Euclidean geometry. But man, truth values and truth tables can be challenging, but they're very useful, especially in geometry. So when I make a statement, it could be true or it could be false. And we learn either way. Alright? So a truth value is just saying that the statement is true or false. So I'm going to write a condition down, and we determine if it's true or not. So let's do this one. So we say if a woman is Hungarian, then she is European. And so then the conditional statement is true, right? The reason that it's true is because Hungary is in Europe. Okay? Now let's do this with math. If a number is divisible by 3, then it is odd. Now there's a lot of odd numbers. In fact, there's an infinitely many amount of odd numbers. Consequently, there's infinitely many numbers divisible by 3. Right? So I couldn't list them all. So what would be a quick way to prove this true or false? Yes?
Come up with something that makes it false, so 30.
Yeah, but what's the fancy word for the one thing that makes it false? What's the fancy word we learned last time? Yes? Counter example. Hey, is 30 divisible by 3?
Yes.
Yeah. So our counter example, 30, is divisible by 3 and it is even. So what can we say about this conditional statement?
It's false.
It's false. Okay. $12 is also divisible by 3. So this total statement is false. Now, we'll dive in a little deeper in just a second. The reason these are false and true is based on the implication, right? The first statement has to be true to imply the second, right? And we'll talk a little bit more about that, although you can have other ways to prove that. So sometimes we want to rearrange our conditional statements in a certain way, and we change them because it's a little easier for us to understand. So let's do that. Let's write some stuff down. My smart board. He's not doing so good. So the conditional statement is the first thing that we just did. All right. And how to write it, basically we're going to say P implies Q, where P is the hypothesis and Q is the conclusion. And an example of that would be like if the measure of angle A equals 15, then angle A is a cube. Okay? I know it's kind of hard to see my writing there. I just kind of skipped this. I guess what I should do is kind of change this around and say P is the hypothesis and Q is the conclusion. All right, and then the symbols go P implies Q, and that's how we would say it. We would say P implies Q. Sometimes we would say if P then Q. Now you could do the converse. And so you kind of flip-flop P and Q. And so you would do, the converse would be if A is a cube, then angle A is 15. That would be Q implies P, or if Q, then P. Does that make sense? Not to be confused with the inverse. We'll do some more examples and this will make a little bit different or more sense. We would say here we negate P and Q.
Mr. Adams?
Yes.
What does that say after then angle A equals
15. Yeah, I'm sorry. I'm trying to fit it. It's on page 91 in your textbook. So if you can't read Mr. Adams' little teeny tiny handwriting, it's on that. But real quick review. The statement is a conditional statement. P is the hypothesis. Q is the conclusion. An example is if the measure of angle A is 15 degrees, then angle A is a cube. For the converse, we flip-flop P and Q, and we say if angle A is a cube, then angle A is 15 degrees. Okay. Now, when you do the inverse of this, you would say if the measure of angle A is not 15, right, then angle A is not a cube. Okay? And the way that we would write that, and Mr. Adams writes it a little different than your book. I do it like this. And that's the negation. So whenever you see this symbol, your textbook does it like this, but Mr. Adams does it like that. The tilde sign refers to the word not or negation. And Mr. Adams uses that symbol instead. That's just how I used it. I'm pretty sure, I'll try to stick to the book, but I'm pretty sure over time I'll just start writing it this way. But they both mean the same thing. It's just saying this statement, but you're inserting the word not. You're negating the statement. Okay, so I'll give you an example. The original statement is, Mr. Adams is wearing a black polo. The negation of that would be Mr. Adams is not wearing a black polo. Does that make sense? Okay, so whenever you see this little symbol, it just means not. We're inserting not. Do you have a question?
Yeah. What does it say next to negate?
Negate P and Q.
Oh.
So we're going to insert in the statements. We'll do some more examples of these where we're going to practice, right? We'll have two statements, a P and a Q, a hypothesis and a conclusion, and we'll go through and write these different statements, and that'll make it a little clearer. I just want to define them for you real quick. So this one will be if not, bless you, P, then not Q. Okay, so if not P, then not Q. And then the last one is what we call the contrapositive. Now that one's a combo of the converse and the inverse. So here we're going to flip and negate P and Q. So that would be angle A is not acute, then angle A is not 15 degrees. And so that would be not Q implies not P. And this would be if not Q, then not P. Okay?
Will you always use Q and B?
Yeah, and then eventually we'll add more statements when we get into syllogisms and the law of detachment. We'll do P, Q, R, S, T, U, V. But we're going to start with just two for now. All right, so now here's the interesting thing. We don't do it in high school, but these things have what we call truth tables and truth values. And basically, here's a cool thing. When this is true, so is this. So these have the same truth tables. They're equivalencies. They mean the same thing. We call those equivalent statements. And like I said, we'll do some examples in a second. So sometimes when you're trying to prove something, it may not be easy to prove with just a conditional statement. However, it might be easier to prove using the contrapositive. And what we know, and we'll just kind of accept, Mr. Adams won't prove it to you today because that might be a little bit over your head today. But what we know is that if I can prove the contrapositive to be true, then the original conditional statement is true as well. Okay? And that's based on truth tables. All right? Also, here's an interesting thing. If this is false, guess what? This is false. So those are equivalent as well.
Yeah.
Does that make sense?
Yeah.
Okay. So these are what we call truth values. So all this stuff right here, we call those truth values.